Hi, I'm here on site at Embedded World 2025, and joining me today is Mark Noland, Technology and Alliances Manager at Kingston Technology. We're going to be talking about the key differences between industrial SSDs and consumer SSDs, as well as the key considerations for choosing an industrial SSD. Mark, thank you for being here.
It's great to be here.
Could you start by providing a quick introduction to yourself?
My name is Mark Noland. I'm the Technology Manager for Industrial SSDs, which is our line of SSDs that go into embedded or purpose-built systems.
Mm-hmm. And could you also introduce Kingston Technology?
So Kingston Technology's been around a good 30 plus years. We've been leaders in DRAM and SSD innovation. Everything from consumer SD cards all the way up to enterprise and industrial products.
That's great, thank you. So why don't we start by talking about some of the trends you're seeing that have been influencing industrial storage and memory products?
So the industrial market has always been sort of like, it's very conservative, because if you're going to build a drive into an appliance or a device, IoT device, washing machine, lawnmower, whatever, you want something that's going to be durable and have a long life. And because of that, you also want to have something that, if you're a manufacturer, you want to have something that has the same controller and firmware and NAND from beginning of life to end of life of that product. Whereas like a consumer drive, there may be a brand or product that's a consumer drive that you can buy retail or e-tail, and that product may have a life of 2 years for its name, but it may have a dozen different BOMs and maybe even several dozen BOMs over the 2 years of its lifespan before it gets an update. Whereas the industrial drives, basically they begin life and they have a lockdown firmware, one BOM, so one controller, one kind of NAND that are applied to it, and so it's a lot more strict setup for a confined BOM that limits any variables that can go wrong. So if you have like 10,000 products out there, you don't want to have some with this drive and some with that drive, and you have to do different variants of firmware updates or to repair any kind of issues in the field.
Sure. So given that we are here at Embedded World, I'm sure it hasn't escaped your notice all the discussion around AI. How do you see increasing adoption of AI affecting SSD capacity requirements?
So one of the big things with AI that I've noticed is a lot of devices that are going to be used as maybe autonomous drones, land-based vehicles, air-based vehicles, water-based vehicles. They need maps. And so usually the maps are not small data, so they might need, we've been getting more and more requests where previously people wanted drives 64 gigs and under, which is something that's not available anymore, because when you go to TLC and QLC NAND, that means bigger drives all the time. But now we're seeing, even in the embedded space with AI, the demand for like 2 and 4 terabyte drives and larger are becoming commonplace.
And on this point about larger drives, have you observed any difficulties that have come out of this demand while operating systems continue to have quite a small footprint?
Well, I mean, the OSs do get a little bigger, but like a lot of industrial applications, the OS is very small and locked down, but a lot of devices are doing more logging in the field, and some might be running like a MySQL database or some kind of database, definitely logging, things like that, where they're writing more to the drives, whereas previously a lot of the devices were just sort of locked down. The version of the OS might be, the OS firmware is just being read from the drive. There's a lot more I/O happening these days.
And so why don't we talk about the key differences between industrial SSDs and consumer SSDs? Can you walk us through it?
Sure. So one of the things I was mentioning about, like, if you have a consumer SSD, is from beginning to end of life of that product, you might have anywhere from a couple of BOMs for that product to a dozen or more BOMs, and depending on how widely distributed it is globally, where that's just not acceptable in the industrial space. Is you need a firm, controlled BOM that's going to be the same from beginning of end to life. But you also need, if there's going to be a change, you need to get like when a part gets replaced. So if the NAND or the controller or something goes end of life, you need to have notification of that. So typically, we give like a 90-day minimum notification. If we know farther in advance, we let our customers know. We're pretty good about sharing any early information, but minimally we'll give a 90-day PCN notification. And our roadmap always, if somebody is, we try and have as much crossover as we can. So if we have a product that we know is going to be end of life maybe 6 months or a year from now, we'll let our customers know that, and then we'll let them know when the next gen product will be coming out so they can qualify that and test it in advance and get it programmed into their system.
Sure. So for engineers, what are the considerations they need to take into account when choosing an industrial SSD? What do they need to know?
One of the things that I've worked at a couple of companies across the industry, and one of the big differences I see with Kingston is our level of support. Is we can support everybody from pre-qualification to qualification to like sales and post support. Is Kingston's very, very good at providing in-depth support for customers. We sell through distribution, industrial distributors, but we actually have no problem meeting directly with customers and we'll put on our distributor's hat and go in and be the industry support for the drive directly. And I think it's one of the real big differences for Kingston is the level of support.
I don't think you can underestimate that, and also just having face-to-face interaction with your customers.
Yeah.
So following on from that, why is supply chain stability really important when you're choosing an industrial SSD?
Well, like I was saying, if you're making say it's an IoT device, a router or a Wi-Fi modem or an electric vacuum, robotic vacuum cleaner, you don't want a whole lot of different variety. So if you have a bug show up somewhere, you want to be able to track it down. And so if you had a product, an IoT device that had 30 different variables for the boot drive, it would make it really difficult to troubleshoot that, whether it was a firmware issue with your motherboard or the CPU or some subsystem or the SSD. And so limiting those BOMs for industrial products, that's one of the reasons it's so important, is that it just limits the variables and when it comes to supporting any kind of issues. So engineers, they want things to be simple and introduce as little variability as they can as far as having to support products.
And you just touched upon it, Mark, but I think it would be a good note to end on. How are you supporting your customers more generally at Kingston?
Pardon?
How are you supporting your customers more generally at Kingston?
We definitely we try and involve ourselves in the qualification. We don't just sell our industrial drives unless they're qualified. So we insist that if you're going to be buying in quantity, so if you buy from DigiKey, you can buy anywhere 10 to 100 drives that you might use to test things out. But when you go to put something into mass production, you're going to be buying 10,000 drives. We definitely want to make sure that you have your qualification locked down, and if there are any issues, we will go and support it and figure out if it's an issue with the drive or whatever. We will have our engineers on site and available online to basically track down any problems that arise with memory or storage products.
Sure. Well, that's great, Mark. So thank you so much for joining me here at Embedded World.
Thanks for having us.